Well, welcome back, YouTube. Episode 22 of Ryan Homestead Project, Skoolie Build. This particular episode is specifically devoted to doing whatever it takes to get external shore power inputs applied to this bus without anything blowing up. So that's where we're headed. Now, in order to do that, I have to go back in time and go through a lot of prep work, show you some things that I did, some ideas that I had to improve the way this works. We're going to run through that, and then we're going to pull out my generator, and we're going to put external AC power on this bus and see what happens. At the point that I'm recording this, I have no idea what's going to happen, so let's go figure it out. Everyone, well, here we are. It is actually Friday, June the 13th, and we are in the bus. We are getting ready to run through a whole bunch of stuff that has been done over the past week. It has been a calamity of errors. I am not going to lie. There is going to probably be a lot of jumping around in the videos. I have been recording stuff all week, and in most cases things came out, in a lot of cases they didn't, so I've tried to redo some of it. So if it seems to jump, there's several reasons. So actually, let me put it to you this way. There's three reasons why this video is going to seem disjointed. Number one, camera guy sucks. Number two, there were audio problems, and most of that was caused by all of the fans and all the other stuff. Number three, there were lighting problems, because in some cases the temperatures were so hot in the bus that I could not turn anything on. Number four, there were cases where I was finding problems and I didn't know what to do, and I had to figure it out. Number five, the biggest challenge that I had was heat in the bus this week, and I had to come up with a solution to do that. And the last point I want to make is, by the way, I said three things, I just iterated five, so for the record I can't count, but that's where we're at. So we're going to start with what I do have that I've recorded over the week, and I am going to be filling in gaps as we go along in this video. It may seem disjointed, I apologize for that, but I want to make sure that everything that I've encountered and everything that I've done has been covered. So that said, let's start running through everything and see what we can come up with. All right, guys, I'm back. It is still Saturday, June the 7th. One of the things that I do want to point out is that I did get, if you can see it back there, my AC input connection back into the inverter. I need to clamp the or tighten up the clamp down there at the bottom, but I haven't done that yet, but I will. So that's back in. The whole point to what I'm trying to do on this video is check out the shore power inputs on both sides, and make sure that both from my generator and my crossover that everything works and nothing shorts and I don't have any problems. And I can also work to identify all of my panels. One of the challenges that I face right now, and I'll see if I can get that to show up, but there are the temperatures inside this bus right now. Inside the compartment, at that point right there where that is 100 degrees. The temperatures on top of my batteries is well over 90. It is hot in here. I can feel it myself. That's well within the operating range of the equipment, but it really concerns me that it is so hot in here, which is why I was alluding to the fact that I need to get my solar and all this other stuff so that I can actually run my ACs full time and make this thing self-sufficient on its own power and keep it cool. One of the other problems that I think I'm running into is that I can turn the power on and these fans will run and it'll cool it down some, but because it's so wide open, it's not very efficient and it's not cooling it down as fast as it should. But at any rate, I wanted to share that with you. That's where I'm sitting at right now. I'm at 100 inside the compartment and sitting well over 90 degrees at the top of my batteries underneath that tape. So it's pretty hot in here, and it was a hot day. It got up to 88 outside. One of the things I will show you as well is that if I go over to my compartment temperature, or my room temperature thermometer, it's sitting at 93 in here. Now, walking up to the front, there is another thing that I thought of, and something that I did today, and I want to walk you through that and show you what I got going on here. So if you see this box right here, this is actually an automatic transfer switch. I've had it probably since September of last year, and I got it before I realized that I didn't need it because the inverters had the transfer switches integrated into them, and so I really didn't need it. But I'm glad I got it because I had an idea with it and I've implemented that idea. So the way that this is set up right now is that I have my load output, which is right here. So it feeds over from here to here, and then this is the actual load output of the transfer switch. This goes into the AC input of my 12 volt inverter. On the top side of this is I have on the top one right here, this is actually the input from my 12 volt 24 volt panel, that if I trip the breaker, I'm getting AC power from my 24 volt side into the transfer switch. I've got this set up as my normal power setup, so that if I trip that breaker, I will get power as inverted, as shore power input to my 12 volt inverter from the 24 volt side. On the other side, I have an input that is considered backup power. Let's see if I can put a little light on the subject without blinding you. But this one is considered backup power. What I have added is I've added a separate shore power input just for my 12 volt side. I've got it wired in. That's what this wire right here is. Comes across. I've left slack in the cable. And then if you look right there, let me put some light on it. I'm not turning anything on because it's extremely hot in here. But there is the shore power input from the outside. I'll take you outside and show you that. The wire comes up, and then one of the things that I have coming in that I'm going to put on this side because of that is I've got a 30 amp EMS that is single pole that I'm going to put in right here. And that will provide capability to protect power. So the way that I have my shore power inputs right now is I can run 50 amp service off of a pole. I can run 30 amp service off of a pole. I can run 15 amp service off of a pole. I can also run 30 amp service split phase off of my generator and 15 amp single phase off of my generator, and provide dedicated shore power inputs to both sides without having to run through my 24 volt side. I have an EMS on the 24 volt side. It's a 50 amp. I put a 30 amp on here because I don't want to be plugging this stuff into something and not know what it is. So I've got those two things done. At this point, I want to walk you outside and show you where I put the shore power inlet and give you a rundown on that real quick. Let's take a walk. All right, well, there it is, guys. 30 amp input. From this, I can get the power cord that I have. I have a 25-foot cord that'll plug into this. It's got an adapter for the other end of it. It will plug into a 30 amp excuse me, a 30 amp receptacle at a power pole, or there's an adapter and I can run it off of a 15 amp circuit out of my generator, or power pole, or house, or whatever the case may be. And so I put that in today, got that all wired in and all set up. This is obviously my 50 amp input, and I've got two cables for this. One that lets me run 50 amps off of a 50 amp service, the other one that lets me run 30 amp split phase off my generator. So got those in place. So let's go. It's getting kind of cluttered out here. I'm running out of space. If it wasn't for those rub rails, I could do a lot more, but I'm running out of space. And I really don't like the idea that I'm putting all those power inputs right next to all those water inputs, but what choice do I have? So let's walk back in and take a look at a few other things. All right, so we're back at the 24 volt side, and one of the things I want to point out is that right here is the EMS for the 24 volt input. That comes off of that round stainless steel plug that will give me up to a 50 amp split phase input onto the power distribution system. One of the things that I did with that dedicated 30 amp is, if you come over here, you can see that I also have another EMS that is dedicated to that 30 amp. I did that because if I go to a power pole at an RV park or anything, I can plug into 15, 30, or 50, or any combination of those. And what I wanted to do was make sure that if I plugged into a 30 or 15 amp on a power pole in an RV park, that I had an EMS to protect my electrical system. So I added this today. I've got everything in. So this side is the actual input side. Comes in, goes through the circuitry of the EMS, comes out on this side. There's one of the sensor right there for the line side input, comes out and goes into the inverter. So I added that to make sure that I have protection no matter what I was connected into, and that nothing was going to give me any problems. So let's move into the 12 volt distribution side and the electrical panel. One of the things that I have done, and I wanted to bring you up to speed on, I had a lot of problems, guys. I made a lot of mistakes. One of the things that I did do, though, is that I used the actual inverter input on the line side here and was able to actually identify all of my shore power inputs, because what I did is that I took every one of the shore power breakers out, segregated them out, and then I used the inverter bus, and I put each one on the inverter bus and identified which one was the shore power for what circuit, so that there would be no mistakes, no issues, no problems, and I knew exactly what everything was. I have to tell you that I'm really glad I did that, because one of the things that I found is my entry circuit here, ENT, this entryway circuit that goes up at the front of the bus. I forgot to cut the tabs that go between one side of the plug and the other. So when I energized the entry on the inverter side, the shore power side lit up as well. I checked every single circuit with lamps, and put lamps on both sides, so if I energize one, I would be able to see if the other side energizes as well. I've made a lot of mistakes, and I want to be extremely cautious and make sure that I don't make any more. Matter of fact, when I installed the EMS in, I put it in backwards. I had that thing backwards, and I had to uninstall it, turn it around, and reinstall it. So I am really careful, cautious, and paying a lot of attention to the way that I'm wiring this up so I don't blow anything up. But right now, every circuit is identified, and I think I've already alluded to this, but I just want to cover it again so there's no mistake. So this is my inverter, AC out 1 on the inverter coming into my panel. This breaker is my kitchen ground fault. I had to remove the ground fault breaker as part of troubleshooting, but this is my kitchen ground fault, and it is on the same bus. This bus is my AC2 input from my inverter. This provides the shore only input to my electrical panel. On this side I have my breaker that's identified as rear shore, which we'll get into. And then we go back, the next level is actually back to inverter. So I have my kitchen plugs and my entertainment circuit that's on the inverter. And then I have my kitchen plugs that are on shore and my entertainment that's on shore. Then I go back to my fridge. I have my fridge, which is primarily on inverter. And I have my front panel, which is primarily on inverter. Next breaker down is fridge shore, front panel shore. And then my last one is my microwave shore, because the microwave gets its originating power from the inverter from the 24 volt side. But the shore side of it comes from this panel. So there's where I'm at. I've got everything labeled, I've got everything identified, I've got everything tested. I think at this point I am ready to put external power on this bus and make sure that everything works. So that's where we're at right now. One of the other things that I have done that I wanted to share with you, just so you're aware, as we've already alluded to in previous conversations, it has been getting extremely hot in this bus. And I was getting all kind of alarms. I have everything connected through Victron Connect and through the VRM portal. I was getting all kind of alarms off of my smart shunts and everything else about overtemp. So one of the things that I did today, besides install the EMS on the 12 volt side, is that I did something that I thought would help cool this down, and it has. One of the things I want to show you is if we're looking over here on the 24 volt side, there's no fans running. And the reason there's no fans running is because I have been able to cool this thing down to 74 degrees. Oh, what a blessing that is. As you can see, the highest temperature is recorded in here is 99 degrees. That is way too hot for this equipment. It's way too hot for the batteries. It's way too hot for everything. So one of the things that I did is I went to the lumberyard today and I got that little handy dandy device right there. Set me back quite a bit. I am not happy about it. It's going to delay install some of the other things that I need to do on the bus until I can get it paid off, but it is what it is. I did not want to lose my investment in my equipment. So that is basically a AC unit that I've got in here. It is plugged into my house. It will be running 24/7. What I can tell you is that I put it in at about 2:30 this afternoon, and then at about 5:30 it had dropped the temperature of the bus by about 3 degrees. But I do have to say that the thermostat was up here at the roof. When I dropped the thermostat down here to where you see it right now, it dropped drastically. I can definitely physically tell the difference of the air temperature in this bus right now. Looking at the battery temperatures and the compartment temperatures right now, they don't match what we're seeing on the other thermometer. I think that I really need to close this off and control the airflow through there, because I don't think that I'm getting efficient cooling in these compartments, both on the 24 volt side, which is here, and the 12 volt side, which is here. What I can tell you though is that, and even though I actually changed the settings just so they wouldn't run constantly, is that the 24 volt side, all the alarm conditions are off. The fans aren't running, because if I turn that on, the fans start running. If I turn it off, they don't run. So that means that there is no alarm conditions that is energized relays that wants to make my fans run. That's a good thing. That brings up another point, is that if you look at my panel, it's all over the map. The inverters are off, so I expect that. But I've got some issues with the way that this is wired on both sides, so I'm gonna have to go through that and try to figure out why that is the way it is, and get that all sorted out. What I have going on back here does not match what I have going on up there in my alarm panel up front either. So I've got to figure that out. The other thing that I did, if you look up there, I've got a window unit that is sitting in my bus that is blowing cold air towards the back of the bus. It is a challenge. I'm going to have to figure some things out, because the backside exhaust of that air conditioner is just blowing hot air right in front. It's probably self-defeating, but it is blowing cold air back here. And guys, I can tell you, it feels a lot better in this bus today than it did yesterday, and it was really hot in here yesterday. But I'm going to sort that out. The biggest challenge that I have is trying to sort out the condensate, making sure that I keep that under control, keep that emptied, and make sure that it's not flooding my bus. This one I've got, let me take you up front and I'll show you what I've got set up here so you can see what I've done. So this is actually a window unit, and when I get up here, so it's blowing cold air, but it's really hot up here. And that's because the air coming out of the back is extremely hot. And if you look down there, I've got that bucket pan sitting there with this thing on an angle, and it's dripping all the condensate into that pan. But it's extremely hot up here, and I think that that is because this is not a very effective and efficient way to use this unit, but it's blowing cold air in my bus. So what I think I'm going to do is use a box fan or something like that to try to vent the hot air out and help this thing work a little bit more effective and efficient. But anyway, that's where we are with that right now. So I've got an AC unit up here that's blowing cold air back. I've got one back there that's blowing cold air front. It is making a huge difference in this bus. I am going to let the ACs run all night. I want them to drop the temperature in here and get it really cold in here, so that the bus has a better chance of withstanding the high temps that we're encountering right now in Virginia. So that's where we're at. So that's what I've got done so far. I will tell you that the entire point of this video at this point in time is to put shore power on this bus from my generator or from a house plug or whatever the case may be, and make sure that nothing blows up and everything works. One of the other things that I want to update you on, and then we'll close this out at this point, is that I came back here yesterday and I worked well into the late evening hours, and I sorted out all of the wiring back here that I said I needed to do so that I could actually close this in and put my mini split up here. So I've got that done. I do need to clean it up. I do need to reroute the wires. I do need to sort it out, but everything is connected and everything is working. I'm going to finish this up, and the whole point to that is to be able to close this up so that I can get my mini split in. I need to get those things in and running, and if I have to, I'll run them off the generator. I'll put them on a house plug. I'm thinking about putting some temporary solar panels up to help charge the batteries and stuff. I'm still sitting pretty good on my batteries on the 24 volt side, but if I turn those mini splits on, that'll change drastically in a heartbeat. 12 volt side, I'm sitting at a point where I need to start worrying about it. Matter of fact, I'm getting to a point where I'm getting a low voltage alarm on my yeah, I'm sitting at I don't know if you can see it, but I'm sitting at 33% on my batteries on the 12 volt side, and it says I've got 6 hours. Now that'll jump up to quite a bit once I turn everything off, but I've got both my max air fans running. I've got all kind of lights running. Got the fans running. I've got all kind of stuff running. So as soon as I turn that off, it'll jump back up. But one of the things that I think I'm going to do is, because of the situation I'm in with temperature and stuff, is I may actually cool this thing down and then use my battery chargers and get the batteries charged back up so that I don't have to worry about it, so I could maybe run this thing all night by itself and let it really cool this thing down. Alright everyone, at this point we are back to the present. It is actually Saturday, June the 14th. It's shortly after noon. This is the moment of truth. This is the final smoke test, bringing AC shore power into the bus and seeing what happens. There are a few things that I want to recap that I missed in the previous parts of the video that I think are important, and I'll just run you through those real quick, and then we'll get everything set up and staged and ready to rock and roll. So first thing I want to do is go through and correct the record on something with the EMS. So let's walk over there and I'll show you that. Alright, so here we have the EMS right here, and earlier in the video I had mentioned that the output of the EMS, which is right here, I made a comment and said that it went to the inverter. Well, it does indirectly. The first place it stops though is actually the input side of the transfer switch. The output of the transfer switch is what actually specifically connects to the inverter. One of the other things that I didn't mention is I put in this block right here, and what this does is ties all of the various inputs and outputs, the ground wires, together. One of the things that I've checked is I've checked and made sure that there is no shorts or anything like that across the transfer switch other than where they're supposed to be, line to line, neutral to neutral, on each of the inputs with the transfer switch engaged. The way that I have the transfer switch set up right now for the purpose of this test is that I have the transfer switch in manual right now, because I want to be able to control when the power gets applied to the inverter. I want to be in here when that happens. I've got it set right now so it's coming from the 24 volt side. 24 volt side is completely off right now, so there's nothing coming in on this side of the transfer switch. So I have it sitting over here, so it's dead. Once I get my generator up and running, I get power applied to it. The first thing I'll be able to do is verify and validate the EMS and make sure that everything is good there. Once I know everything is good there, I'll check and make sure that I've got power on the input side of the transfer switch. The entire 12 volt system will be energized at that point. We'll run through and make sure that all of the inverted outputs are working, and then I've got power on all the different circuits. So the way that this is going to be set up is, the first thing I need to do is verify and validate my configurations and make sure that the ground relay on the 12 volt inverter is disabled, because the ground relay is actually connected, neutral to bond ground is actually in my generator at this point. So I've got to make sure that that's off, and at which point I will be able to power up the generator, get power to the top side of the transfer switch, and make sure that that's working. As soon as that is verified and validated, then I should be able to manually engage the transfer switch, and we should be able to see shore power hit the inverter and start registering on the inverter. It should start charging my batteries. I've got the input limit on this right now set to 15. The circuit on my generator is actually 20 amps, but I'm leaving it restricted to 15 for the purpose of this test. So once we've got this setup done, then I'm going to go, because the ground relay will be off, I'm going to turn off and disconnect the generator, and then I'm going to energize the 24 volt side, make sure that the ground relay is actually energized on that side, and then we're going to do the transfer power from the 24 volt side over to the 12 volt side. Again, I'm going to leave this in manual. I'm going to make sure that when I do that, I can test and validate that it is coming into the top of the transfer switch correctly. Once I've verified and validated that it's coming into the top of the transfer switch correctly, I'll engage it. at which point we should see the AC power from the 24 volt side hit the inverter again, and we should see that it starts charging batteries and all of those kind of things. At each stage, we are going to be verifying that the input from AC2 hits the shore only side of the panel, and that we've got shore only power hitting all the various circuits, and that everything is coming on there. Once we get done with that, then I'm going to turn off and disconnect everything. I'm going to verify and validate that the ground relay on the 24 volt side is off. Then I'm going to apply my 30 amp split phase output out of the generator into the EMS on the 24 volt side, again making sure that everything is good there. Once I've been able to do that, we should be able to see that we've got inverted power on the inverters on that side, and that they would be charging the batteries as well. Once I've got that set up, then I'll also test that transfer capability again, running off of generator power. I won't be touching anything on the 12 volt side after the initial test with the generator, because it will remain the same throughout the entirety of the test. The only thing that I'll have to do is verify and validate ground relays on the 24 volt side. So that's what we've got going on. One of the other things that I do, I want to show you the setup and staging that I have in place. So let's look at that, and then I've got to show you a serious mistake and poor judgment and lack of attention to detail on something that I did. So let's start off with that. So as you can see right here, I've got two lamps. The back lamp back here is actually connected to inverter power. The front lamp here is actually connected to shore power. Both of those lamps are tied to my fridge circuit. So we'll be able to see both of them light up. Then I will be able to kill the inverter breaker, and we should see only shore lit up. But they should both light up once we get power on the AC2 outside of the circuit breaker. Over here I've got this lamp that I pulled from up front. I've got it plugged into my microwave shore output. I've unplugged the microwave for the purpose of this test. I would rather blow up a light bulb than blow up a microwave, so just in case, just a little bit of safety and precaution. I'll move the light from one to the other, but I will tell you that this particular light right here created a very serious problem for me, and I can't believe that I didn't pay attention to it and catch it. But let me show you what it did. If you remember in the earlier test, I had this thing standing up here in the front as part of the entry and front panel circuit test that I did up here. Well, one of the things that I completely screwed up on is realizing, number one, I did not have an LED bulb in there, and number two, the height of that thing, I had it wedged in. Well, look at what that light bulb did to my insulation. I am so happy this stuff is fire retardant. It actually melted all the insulation, so I'm going to have to figure out a way to patch that and get that insulated again, but I cannot believe I did that. Got to pay attention. I have no idea. Number one, it never smoked or anything. I didn't see anything, didn't smell anything, but that light bulb surely melted the hell out of that foam insulation up there. So I can't believe I did it, but I did, and now I gotta fix it, but it could have been a lot worse. So poor judgment and lack of attention to detail on my part with that, but anyway, I just wanted to share that with you. Everything's not perfect. So with that, I think we're going to go back here. I want to try to show you a few things. I want to recap a couple of things that I did do over the week that I didn't talk about in any of the previous videos that I did. One day last week, I think it was Thursday. Yes, actually it was Thursday. One of the things that I did was I came through both my 12 and 24 volt side. I changed the pins on every single device in here so that I wouldn't have to be constantly trying to figure out what the pin was. So I've got that all set and configured. I made sure that every single device was on the Victron Connect on my computer. I made sure that I could see every single device on the VRM portal. The only thing that right now that's connected to VRM is my laptop. I've got to get my phone connected to that as well. One of the challenges that I seem to be realizing, and I don't know if I'm screwing up or if that's just the way it is, but I have created several configuration files. Let me move this out of the way, and then I'll be able to show you what I'm talking about. But as you can see, I've got several configuration files right here. I don't know if you can read it. It's hard for me to tell in the screen of the GoPro. But I've got a 12-volt grid configuration set. I've got a 12-volt off-grid configuration set. I've got a 12-volt shore set with 15 amp current limit, and I've got a 12-volt shore set with based on a 30 amp input. The current limits on those are a little bit different, but not much, and I've just got those. The thing that I have is that the off-grid configuration basically very specifically has my 12-volt inverter ground relay connected. I tested going back and forth between all of these and loading and setting the configurations and stuff. It does not seem to change the ground relay, and I have to go in and manually change that after the fact. So just be aware of that. Don't assume. Maybe I'm doing something wrong, I don't know, but in every case, no matter which way I go across the board, the ground relay, when I load different configurations, regardless, going like off-grid has ground relay energized, and the 12-volt shore set 15 has ground relay disconnected. If I go back and forth between those two, ground relay is not affected. Whatever way it was, if I turn it off, if I load the off-grid one where it should be on, it's not on. So have to do the ground relay manually, at least based on the way that I'm doing it. I don't know, maybe I'm doing something wrong, but it is what it is. It's just something to be aware of. Please make sure that you verify and validate that, and if you can figure out that I'm doing something wrong, please let me know. I would appreciate it. So at this particular point in time, I've got everything set and ready. What I'm going to do is shut this down right now. I'm going to get my 12-volt side up, let my servo run up. I'm going to make sure that my MK3 is connected. I'm going to verify and validate that I've got connection to my computer. We all know what that can be like. And I'm going to turn on my generator and let it warm up before I apply power, and then we're going to see what happens. I'm not going to lie, I'm really stressed out because I'm constantly trying to figure out if I made a mistake somewhere, if I overlooked something, if I did something wrong, and it's not going to work and something very bad is going to happen. But we'll figure it out together. So with that, I'm going to turn this off and set the stage for us to do our first part of the test. Alright, so at this point I'm ready to make sure that the configurations on my inverter are ready for the shore power input. I do have to correct the record. It seems that I may have been doing something wrong because at this particular point in time, right there where my mouse is, I'm really not sure if you can see it or not. I hope it's coming through, but right there where that check mark is, that is my ground relay. I've got this set on my off-grid settings, which means the ground relay should be energized. So if I go to target, actually file, go to load settings, and then I select my 12-volt shore 15, which is what I need right now, and I open that file, ground relay goes off. So apparently I was doing something wrong. At this point it is working. When I load the settings, the ground relay does go on and off the way I expect it to. So I've got the ground relay off right now on my inverter. My charger is set up as well. It's ready to rock and roll. Going back to general, I've got 60 hertz. My AC input current limit is set right here at 15 amps. So at this point in time, the 12-volt inverter is set and staged to accept generator power. So at this particular point in time, I am going to go fire up my generator. I am going to get the AC input applied to the top side of the transfer switch, and we'll see what happens. I'll be right back. Alright guys, this is the moment of truth. As you can see right here in the Servo GX screen, it says Shore is disconnected. My inverter is on and it's inverting. My AC loads at present is 13 watts based on the lights that I have on in here. My batteries are at 95%, so I'm good right there. I don't have any solar inputs, and my DC loads are running about 85 watts. So at this particular point in time, everything is working as it should. I'm going to now go and bring AC power up to the transfer switch and measure that and see what's going on. So I'm going to go do that right now, and then we'll come back and see what happens here. Alright folks, I have power into the bus from my generator. As you can see, I've got some LEDs on my EMS right there. There is power in there, so I'm not going to get too close. The other thing that I do want to show you, if I come down here to my transfer switch, it is telling me that I have power on this side, the backup power side of the transfer switch. One of the other things that I want to show you, if we come up top here, where the display is for my EMS, as you can see, I've got 121 volts, 0 amps, and E0 means everything is good. So that's why I have power to my transfer switch. If there was an issue with anything, I would get an error code that would be other than E0, and it would not have power on the transfer switch. So I think at this particular point in time, we're going to flip the switch, see what happens. Let's do it. The switch is flipped. And the relay just energized. It is still telling me no guys, I have a problem. I think it just tripped the breaker on my generator. I'm gonna have to shut her down. Alright guys, I'm back. So I figured out what was going on. It did not trip the breaker on the generator. What it did do is trip the ground fault on the plug that it's plugged into. One of the things that I did, thinking maybe too much surge on the generator at once for that circuit, so I lowered the AC input current limit. I'm going to try this one more time. If it trips that breaker, I'm going to do some research on that generator. I may need to bring that ground relay in, because maybe, just maybe, neutral to ground bond is not at the generator. So I'm going to find that out, and we'll see what happens. So at this point, everything is back up and running. I've got the transfer switch back in the off position. You can see that Shore is definitely disconnected right now. So let's see what happens again. It's going through its cycle to transfer. Nope, same thing again. All right, so I got to figure out why I'm tripping the ground fault on my generator. So I'm going to shut it down. I'm going to do some research, going to do some homework, and see if I can figure that out, and then I'll be back. All right, everyone, I'm back. I have success. I just don't have it with my generator. As you can see, I've got it switched over. I've got power coming out here, power coming into the backup power input. My EMS is still on. If I come up to the top, it is still registering that I'm at 113 volts, 9 amps, 60 hertz, and an E0 indication, which means everything is working as it should. One of the things that I do want to show you is that on my battery monitor, I'm pulling about 65 amps coming over here. The reason for that is that it is in a bulk charging state for my batteries, because they're a little bit on the bottom side. I'm pulling 1035, let's call it 1040, 1040 watts off of my Shore input. At this particular point in time, it looks like that's working. So let me explain what I did. I have a ground fault circuit that is feeding 115 volt power receptacles on my hot tub deck. So rather than using the generator, I went over and plugged it into one of the receptacles on my hot tub deck. Be advised that they are all protected by a ground fault circuit interrupter. The main difference is that I know that the ground neutral to ground bond is at the panel in my house. Doing some research on the generator, it seems that the neutral is tied to the chassis, but the chassis is not grounded to anything, and it's not on the same ground plane as the bus. So therein lies the issue with my ground faults on that generator tripping. At least that's what I think. I don't know. All I know is that on the generator it don't work. It trips the ground fault. On a ground fault that is tied to the panel in my house, it does. I do now have Shore power coming in to my 12 volt inverter. And if we go down here, you can see that I have my charger on and it's in bulk charging mode. Those are the two relay lights that you see right there. The inverter is on. It is providing an output. As you can see, my lamp for primary power is still on. So now the big test, and the test of the day, is to find out if the AC2 output actually has power, and I can actually get power from the AC2 side of the inverter to all the circuits. So it's going to be difficult because I got power on. What I'm going to do is I'm going to set this down. I'm actually going to measure the voltage at the input of the circuit breaker for the Shore side of the panel and make sure I've got 120 volts there before I energize that, and we'll see what happens. I'll be right back. And that works. The voltage across the line 2 input of my panel is also at 113. I'm going to have to hurry up and get this tested, because one of the challenges that I'm facing with this is that this is running off of a 12 gauge extension cord right now. I'm only pulling 10 amps and it's rated for more than that, but I'm getting a lot of line loss and it's going to start heating up. So we're going to do a quick check on Shore only and see what happens. Alright, Shore only is on. So if I go and if I turn on my fridge Shore, that lamp should light up. And it does. Ladies and gentlemen, we have success. If I turn on my microwave Shore, which is right here, that light lights up. Holy cow, guys, it worked. I have Shore power inputs on my panel. So at this point, I think it's time to move on to the next stage. I don't want to press my luck with that cord, but wow, I'm happy. So I'm going to transition all of this. I'm going to unplug that extension cord because I don't want to keep doing that. And with that said, I'm going to call this one a success. I've got power on both my primary inverter side of the panel, and I've got power on my Shore side of the panel, as you can see, with both of those lamps on at the same time. Holy cow, it worked. All right, now I need to do the same thing and test on the 24 volt side. I'm wondering if that generator is going to provide the power that I need to test the Shore input on the 24 volt side. It's not ground fault, so maybe it will, but we'll find out. So at this point, I'm going to shut her down and transition. Actually, before I shut this down, there is one thing that I did want to show you. I have the VRM portal up, and the VRM portal is on my computer screen. As you can see, I'm showing that I'm getting 1035 watts coming in on my Shore side. I've got 130 watts for DC output. I am currently charging my batteries and they're at 95.3%. I do not have a solar input, as you can see right here. and my AC loads right now are currently at about 10 watts, give or take. I did, just to show you, I do have my input current limit at 10 amps on that side. So this is actually the VRM portal, and it's registering everything on my 12 volt DC system. So I wanted to give you a little bit of a screenshot on that, because I forgot to, I had it set in stage, but I forgot to bring it up. So I came back so I could show you that, and now we're going to transition. All right, guys, we're going to shift gears. I'm about ready to get hit by a thunderstorm, so I had to cover up my generator, and I can't do that part of it right now. So what I did was I re-engaged the ground relay on the 24 volt side. I've got it set up. I am going to now actually test the 24 volt crossover from the 24 volt side to the 12 volt side. Right now you can see I don't have anything applied to my transfer switch, and it's in the bottom position. The bottom position was the actual shore power input, the 30 amp shore power input from over here. So once I can get and verify power on this side, then I'll know that I have power to the transfer switch. I can manually cross it over, and everything on the shore side should start working again. It's time to press the test and see what happens. I do want to validate that I've got all of my shore power breakers are off on this side for right now. And actually it looks like I've got all of my, I don't have anything on there. Oh, that's right, I moved the breakers. So I got 24 volts on, inverter is on, so that light right there is actually coming off of the 24 volt side, which is the inverted output on the 24 volt side for the microwave. Coming back here, going into the plug that was in the back. On the top side of the plug is inverted output coming from the 24 volt side as well, and that's on. So I've got AC output. Also, if you remember, I have that cord right there. I've got that plugged in and the breaker turned on, so I've got split phase going across everything, so that's working as well. So at this point in time, and I apologize for the noise, but all the fans are on because it's hot here. At this point in time, I'm going to cross my fingers and see what happens, because I've got AC power. So as soon as I trip that 30 amp breaker, I should have power sitting on the top side of that inverter. And when I flip it over, I should get AC shore power connected to my inverter on the 12 volt side. Wish me luck, guys. Let's see what happens. I'm gonna leave this right here and put it down to the transfer switch so that those lights come on, you'll be able to see it in real time. So let's see what happens. Okay, I have power to the top side of my transfer switch, and I think I'm ready to trip it over and see what happens on this side. Oh, I'm stressed out, guys. Holy cow, it worked. I'm pulling 1100 watts from the 24 volt side. Everything is up and running. So if I start hitting some of my shore power breakers, well, I gotta turn the shore power on. Alright, something doesn't seem to be right now. I don't seem to have power on the AC2 side of things. So I'm going to troubleshoot that, and I'll be back and let you know what happens. Alright, I'm back. I don't know what happened, guys. It's working. I must have been doing something wrong. But that right there is running off of the shore-only side of my panel. And the shore-only side of my panel is being fed by the AC2 out on my 12 volt inverter. the AC in on my 12-volt inverter is now crossing over and feeding from my inverters on the 24-volt side. If you notice right here, oh, I don't have the servo connected to the inverter, so that's not going to work. But as you can see, it's starting to get a high temp alarm on my smart shunt, but everything's working. You can see I've got a pretty heavy-duty DC load right now. That's because the inverters are actually outputting power. Coming over here, you can see that I do have shore power input, and I'm pulling 1100 watts. I'm currently in a bulk charging state from my inverter charger onto my batteries. And I am charging my batteries, and I'm currently charging at a rate of 66 amps. Or actually, yeah, 66 amps, because if you look right here, the battery monitor is saying I'm at a plus 67. So I'm charging my batteries with 67 amps right now. That's awesome. At this particular point in time, everything's working. Oh my God, I'm so happy. Love it when a plan comes together. So that's where everything is. The only thing that I need to do is wait for the storm to pass, and then I can hook up my generator, and then I'll be able to check generator input and my EMS on the 24-volt side, get that verified and validated, and then the last step in the process will be to put power on both sides of that transfer switch and see if it works. So in an automatic perspective. So I'm going to shut it down right here. I'll be back as soon as the weather breaks, and we'll finish this up and call it a wrap. All right, so I had an idea while I'm waiting for this weather to pass. I went ahead and put my 15 amp power back into the receptacle by my hot tub. As you can see right now, I've got power coming into both sides of the transfer switch. So what I want to do at this point is I want to actually test the transfer switch and make sure that it's automatic. So what I'm going to do is I'm going to flip that switch over to automatic. It should stay right where it is because it is on the normal power side. At that point, I will go and actually trip the breaker that provides the normal power input to the transfer switch. When I do that, it should automatically rotate and switch over to the plug on the outside. Please note the EMS is on, LEDs there. Let's go check the panel. I am 121 volts, 0 amps, 60 hertz, E0. Everything is normal. So I'm going to set this down and then run through those steps. I'm going to try to fix it so you can see it as it happens. There it is. All right. Try to get this closer so you can see it. All right, so at this point, I'm going to switch to auto. Nothing changed. So now if I go trip the breaker that is providing the shore power crossover from my 24-volt side to my 12-volt side, we should be able to watch in real time and see that transfer switch over. So let's see what happens. Ladies and gentlemen, it worked. So now what I'm going to do, and I'm going to go back the other way, I'm going to turn my primary input into the transfer switch back on. And when I do that, it should switch back to the way it ever was. Boom! We have success. Holy cow. So the only thing that I have not tested at this particular point in time is the 30 amp split phase input on my generator through the EMS and into the inverter. So we'll see what happens with that as soon as we get a break in the weather. I do want to show you something though. So in about 20 minutes, this thing has gone from bulk charging at about 95% to absorption charging at 100%. Notice that the battery draw is at 0 amps. I'm at idle, so basically everything that is coming across from the 24 volt side is providing all the power for over here. Nothing is discharging, nothing is charging, it's just sitting there. That's a good thing. So at this point I'm sitting at 100%, back up to 416 amp hours on my batteries, and everything, to be honest with you, at this point on the 12 volt side is running strictly off of the 24 volt side. So I call that success. Coming over here to the 24 volt side, my inverter is showing off because I do not have it connected to the servo. It's still connected to the MK3 because I got to do the ground relay manipulation. But my battery capacity on the 24 volt side has dropped from 100% down to 93. And it's basically saying I've got 27 hours left on this side in the current state in which it's running. I'm not sure I understand what's going on with my battery monitor here. That is way off. It's not reading. There's something up with that. I'm gonna have to check that out. But that's where it stands. It is dropping, but the battery stuff is not updating, so I don't know what's going on there. But I'll see. Anyway, so at this point, everything has checked good on both sides. Transfer switch is good. The only thing that I have not tested at this point is the inverter split phase input into my 24 volt system and validating that my EMS works. So as soon as I break in the weather, we'll come back and we'll get that done. All right, guys, I got to break in the weather, so I'm going to go ahead and do this. I got my generator up and running. I got it stabilized. All I got to do is go outside and trip the breaker, and we'll be able to see what happens. I'm going to put this so you can see it on the VRM portal. I've got it on this particular system. When I trip the breaker, it should actually show that I've got shore power coming in on the inverter, and we'll see what happens. Unlike the 12 volt side, I don't have the transfer switch in the way to actually control when it gets applied. So as soon as I trip that breaker, it's going to go through the EMS. If there's no problems with the EMS, it's going to hit the inverter. So that's the only thing I got going on, is that if there's something wrong, the EMS will protect it. So at this point, I'm going to trip that breaker, and we're going to see what happens. The first thing I do want to do, though, is so that there's not as much of a surge on my generator, is I'm going to trip the shore power crossover, so there's not as much current coming out of this side, and then I'll bring it back in after I get it on generator. And the transfer was successful, so I'm now running off of that plug. I've got to hurry up because my battery's about to die, so I want to make sure you see this. So I'm going to trip a breaker and we'll see what happens. Breaker is on. Mains are on. That shows that it is on shore power off of my generator running right now. That is awesome. My batteries are currently charging at 86 amps. I've got 70 plus watts on L1, very little on L2. My shore power though, I'm running 2800 watts, 1600 on L1 and 1100 on L2. Ladies and gentlemen, my smoke test on my system across the board has been a total success. As you can see right now, everything in here is running off of the generator. It is currently bulk charging my batteries off of the generator. I'm running 2700 watts off of my generator right now. On 240 I can run up to 7,000, so I am well within the range of that. Holy cow, guys, it worked. I can't believe it. So at this point, the only thing that I need to do is to do the shore power crossover running off the generator and see what happens there, and then we'll shut it down. Hopefully my battery lasts long enough for me to do that. Transfer switch just kicked over. Shore is now connected off of the generator on the 12-volt side. And everything seems to still be functioning as it should. I am both charging at present. The shore power wattage for each of the lines did not go up very much. One of the things that I do want to bring into the picture and show you real quick, and then we'll call it, is if you look at my EMS, I'm running 19 amps, L2, 120 volts, 18 amps, 60 hertz, E0. Everything is working, everything is configured correctly. I have no electrical problems. Smoke test, part 3 is complete. All of this stuff is working. So at this point, I'm shutting it down. I'm going to wrap this video up and I'm going to get it out. I'm excited. Have a great day. Oh, by the way, just so you're aware, tomorrow is going to be Father's Day, and I probably won't be on camera tomorrow because I have to work, but I just want to wish everybody a happy Father's Day if you're a father. If you're a mother, happy Mother's Day. So have a great one, guys. Okay, one final thing that I do want to wrap up with before I close this out is there are the shore power inputs. So this is the actual 30 amp single phase input that was providing shore power to the 12-volt side. This is the split phase power input that was connected to the generator. My generator right there, it's a 8750 inverter generator. I'm really happy with that thing. I still have no idea what was going on with those ground fault circuits on that generator and why they wouldn't run, but I don't care. Because if I have to, I can just plug into the 30 amp split phase, and as we can see, I can cross over from one side to the other and do the same thing. So everything is good, everything is a success. I'm really happy, I'm really excited. I was really stressing about this, and as it turns out, all my cable building was good, all my plug installations was good, all my wiring installations was good, short of all the mistakes that I made along the way, and got it all corrected. But we're in good shape. Everything is working. This thing has power, and I'm ready to move on to the next phase. So thank you very much.